derivatives. How have we been applying them? Give me a function and its derivative, and what were we finding from it yesterday? Good. And now if we just make some hand signals here, if it goes from increasing to decreasing, every time. Here we go. Increasing to decreasing. We'll just do that. That makes more sense. What have I just identified? So we're really truly finding the extrema as an extension of that. But you're right. We are just finding where does it increase, where does it decrease. Now, here's the cool part. This problem, and do you want to like debrief on yesterday's, or can we just jump in and continue? Okay. Yesterday's problem, I gave you a derivative and stuff, or I gave you a function and said, hey, find me the derivative, and we did it, and we put it on a number line, we did all that normal stuff. The good news is that that's not the only way I can present these problems. So mine's going to be obnoxiously large, just so everybody can see it. I have a wonderful y-axis right here. Then right in the middle, I'm going to have this excellent x-axis. Okay. From this, we're going to sketch a graph. Now, I'm going to pick two values, and I have grids, but I can't really see them. You guys can see it really well, and I wish I could see it well on my computer. I just can't. I see the big lines. The little ticks are hard, though. So let's say that here is 1. And then down here, if we make it the same, is -1. And I'm not being like, you don't have to be crazy about the same or not. And then however you count out, I don't really care, but I need you to go to 6. So on mine, I'm just going to put a tick here. There's 1, 2, 3, 4, 5, and 6. And I'll just say here is 1 so that I don't have to do all the labels, right? It's all the same scale, it's consistent. Now, we're going to put a graph on this bad boy. Just this. And it's not going to be a crazy graph, but it does have to be specific. So we are going to start our graph. And do you guys have a scale, or do you need another second? Cool. I'm going to start with an open circle right at the origin. From that, I'm going to go down to the point 1, -1. I'm going to connect them with a straight line. And then I'm going to stay at -1 until I get to where x equals 3. And I'm going to identify another point here. I'm going to cross the graph at 4. And then I'm going to go up to the point 5, 1. So there's that one. And we finish with a horizontal line running to the point 6, 1. Now, I've given you a kind of ugly graph. I was trying to put those two things together, a graph. As we look at it, here's the cool part. The graph that I have given you is the graph of f prime of x. Cool. So, couple things, and by a couple I mean 8 things that I'm going to ask you about this graph, and we're going to hit all of them. Okay, instead of saying like b sub 1, we're just going to address 8 questions with this graph in mind. Cool? Like, so we don't have to work out the notation stuff, and I'll start them here, and they'll likely work up to over here. But the first one, I want you guys to, and I'm going to switch to not blue because it's hard to see for that other screen over there. So for the first part of this, I want you to find me whatever this is asking. And the follow-up question is, what is this asking? The domain of f prime. And coincidentally, unfortunately, we've been given the graph of f prime. So right now the question is just what's the domain of this? I'm going to give you like 15 seconds. We're going to see if we get the same thing. I'm going to call one random person. 15 seconds. What is the domain of this green function? Anybody feeling good, or do I just calculator it? Vern, we made eye contact for a brief second. What's the domain of this?
I said x such that x is greater than or equal to 6, but then greater than 0, but less than or equal to 6.
So 0 is less than x, which is less than or equal to 6. Love it. Is this the only way we can write it? Follow-up question. Somebody in here probably doesn't quite understand. Maybe. Any questions on how we get this? Can you explain to me how we got that? Good, all the x values. Now, we might all think about this in a slightly different way. Here's what's literally happening in my mind. Now, I have this graph in my head and I have to use a little bit of imagination, but I imagine this line. And I just wonder, where does it hit? And do we all agree it starts almost here? It just keeps touching and touching and touching until right here. That's all that we did. How did Fern know that it was or equal to here, but just less than here? Open or close dot. Awesome. So nothing crazy going on there. Cool. Doable. Okay, we're going to build up complexity. Step 2. I want you to find me the critical values of f prime. And I lied. I'm going to call this the critical values of f. And we're going to see why I changed that. If I want the critical values of a function, how do I find them? From its derivative, right? So when I talk about the critical values of f, this is the derivative. If I said the critical values of f prime, we'd have to think about the second derivative, which I don't want to do right now. Okay. Where are the critical values of this thing? Say that again. 4. I agree. There's one of them. It's the root of that. So I see 1 at x equals 4. Is there another one? Anywhere where f prime is undefined. 0. Now, that's a weird one because it's at the end point, but it is undefined right here, yeah? And I can see it. Cool. Undefined. Super hard. Okay. Let's keep kicking then. On 3, I want us to address, where are there any x's where f, not f prime, has a horizontal tangent? Now, we are digging through the pieces here, and we got to put several of them together. Talk it out with your neighbors. I'm going to do a little editing magic here. I want to see what you guys come up with, because I don't know that we need to talk in detail about all of them. I'm going to pause the video, and I'm going to write 4, 5, 6, 7, and 8, and I want to see, I'm going to give you guys a couple minutes. Chat with one another, and then we'll just debrief on all of them. Cool. So, you can chat with your neighbors here. I'm not going to talk as I do this, but I am going to write a bunch more questions. So start talking them out, and by the time you finish talking this, you'll plonky as I wrote it, and I was trying to put my head around it. Remember that critical values, if you give me, and I gotta, maybe I can just slide over. I'm just going to check here real quick, see if this is a critical values section. It was not. If you look back at critical values, when we defined them, we said, give me a closed interval from A to B, and then on the open interval is where we find our critical numbers. One of these is not in this interval from 0 to 6. Because that's my domain, right? 0 to 6. Which of these is not in that open interval? So what I want you to do, don't erase it. It has to be the open interval. We can't say that it's critical number there because it's not in the open interval. My bad, sorry about that. It has to be, if you give me A to B and it's closed and it's points on both ends, we find critical numbers in this interval with open on either end. So even if this had been closed, if it had been closed, we still wouldn't include it because it's an endpoint. Cool. All right. So where does f have a horizontal tangent line? And I'm going to use some fancy writing here. But number 11, what do you think? I'm going to say for all x, and you're going to finish this in, I don't know who number 11 is.
Wait, number 11, that's me.
Okay.
0?
So I would agree, except we can't actually define it there, so we can't say the slope is 0. And this one might be weird, because people are going to be tempted. I heard 1 to 4 showing up with people's answers, or 1 to 3. But be very careful. What is the slope of the tangent line between any of these points? So careful. I disagree. The slope of this line is 0. What you're telling me right now is, where is f prime have a slope that's constant? Like, that's not the right question. We're given f, right? Or sorry, f prime. And if it's a horizontal tangent line, then f prime must be 0. Is f prime 0 right here? Is it 0 anywhere? Only one value, right? It's just right here. This is the only place where the slope of my tangent line, which is the value of f prime, is 0. I do agree with you that this is a slope of 0, but that's not the question. It's where does f have a horizontal tangent? Only when this slope is 0. This is the only point. Okay, Now, this is going to be weird because I was expecting an interval when somebody gave me the answer. If I've already committed and I don't want to erase, can I write an interval with one number? It's weird, and it's pretty rare. What's the only number where it happens? Boom. That's my interval. It's weird because it's not really truly an interval, but it's just from 4 to 4. It's just this number. Okay, only place. If this were f, just to really specify, if this were f and I said where does f have a horizontal tangent line, you would be correct. Because we're looking at the value of the derivative is all. Okay, what about vertical tangents? What makes a vertical tangent line? It's where my derivative is something. What's this slope real quick? So that's a horizontal line. What's this slope? Bless you, by the way. Undefined. Is there any place here to here where my slope is undefined? So notice when I move my hands, I'm not anywhere from here to here where that happens. Now I don't really know what's going on here, right? Like we can't be sure. Do I see f prime get like infinitely large anywhere? Because that's what it would mean. I'd have to get bigger and bigger and bigger, right? Do you see it ever doing that? F prime never like shoots up to infinity or anything, which means are we ever gonna have this? None of them. Or nowhere, I guess, is probably the better answer. But that just doesn't happen. We don't see the derivative shoot up to infinity anywhere. Okay, does f have any sharp turns? We're all going to get goofed up here. I saw yes and no just now. Let me rephrase this just to make sure we can see if we find the error in logic. Does this graph have any sharp turns? Just this graph of f prime. Does this one have sharp turns? I think that is. Like I know it's not as like accentuated as the ones that we normally see, but there's definitely a sharp where I go from this slope to immediately another slope. Okay, so that changes. Now, on this one, if we think about sharp turns, and I'm going to think about a f function, if we think about a sharp turn and what it means, what would the derivative be on this part of it? And you don't need to draw this unless you want to. Just give me a number. F prime is, I don't know, -3? I don't really have a scale, right? What's f prime here? Do we ever see this happening? It's like it's an immediate change in my derivative is what makes a sharp turn, because that breaks my limit. Does that ever happen on this graph? So because that never happens, and this is the derivative, did this ever happen on the other one? No, we would have to see that discontinuity of the derivative. Doesn't happen. No. Doesn't have any sharp turns. There's no place where my derivative does this. And for those of you that are watching the video later, this is what I keep referencing with my hands. That's a sharp turn on a derivative or of a function. Okay, where's f increasing? And this one I will do. For all x in which interval number 2? So I'm going to change the question a little bit. If f is increasing, its slope must be positive. This is the slope of f at every point, right? Where is this function positive? Like, you tell me when it starts being positive. Okay, so natural to say this. You're not correct, but we're going to clean it up. Because I'm sure anybody else want to say here. It's just Makisha's the only person that was asking. Naturally, this is a choice. But we have to be really careful. We're asking questions about f, and we're given this graph, right? So I know that something is increasing when its slope is positive. And these are all slopes. Is it positive? Like, and I'm going to word this question carefully. Is the value of my function positive right here? No. Is the slope of this graph positive right here? But that's not what we're asking. We're asking about the original function f. At what point does my function, my green graph, turn positive? Not its slope, but its actual value. From here onward. So in that situation, anywhere to the right of 4, I have a positive slope, which means the function must have been increasing. So we're just going to say from 4 to where? Certainly to 5. Because the slope here is still 1, right? Like it's still increasing. It's a positive. Not 7, but if you just counted wrong, 4 to 7. And what do you think, closed or open? Closed? Why? Okay. Because JJ said 7 and I corrected him and then I wrote 7. I don't know, because I miswrote it. That's my bad. Not you. That's my bad. 4 to 6. And closed? We might have to think about that one more, but I'm cool with it now. Where's it decreasing? Number 7. I don't know who that is. Sean!
I guess
0 to 4. I agree with you. And let's take a look back at this other one, because it's been bugging me the whole time. If I were to take the derivative here, can you tell me what the derivative is from the left of 6? It's 1. Can you tell me what the derivative is from the right of 6? You can't, right? It doesn't even make sense to talk about. Because I can't tell you the right and the left derivative are the same, should we really close this? Okay, let's go back and fix that one. We're going to make this instead. We can't take the derivative at a single point. We have to be able to do it from both sides. Okay, so 0 to 4, and with that in mind, parenthesis or bracket? So I heard both. If I included a bracket, I would include 4, and what's the value of this derivative at 4? And if the slope is 0, is it increasing? So I can include it. I cannot include it, just in case that wasn't clear. We'll use parentheses. This problem covers all the exact same stuff as our previous one. What's cool about this is, out of curiosity, and I don't know the answer, which one's harder? This question or this question A that we did yesterday? I think A is harder. This is so much more conceptual. We're not doing a ton of calculus other than just making sure we understand what it's asking. These will show up. I guarantee there will be a problem like this, at least one. There'll probably be multiple on the AP test. We will start working through our AP practice stuff after the break. With that said, you guys have like 15 minutes. I thought we were going to have way more time than that. But I want you guys to did we do any problems from this? We did mean value theorem stuff, right? Okay. Did we hand it in? Is that what you just handed in? Okay. So we're going to hand in or add to this. This is still 4.3, and if you guys still have the assignment, is that true? No. I handed it in? Okay. 4.3.2. You guys will find this waiting for you on page 309. And I want you guys to do the following problems. We have 37 for T5, 4T7, 4T9, and then you get AP 1, 2, 4, 5, and 6. Cool. You could just say 1 through 6, skip 3, because we did AP number 3 on the other assignment. Cool. I'm going to give you guys 12 minutes to work on this. I'm going to write it on the back board. I'm going to post it to the Google Classroom. Cool. Trabaja.